grounding requirements for a cord and plug connected UPS depend on the electrical code and regulations applicable to the location. Here are some general guidelines based on the National Electrical Code, or NEC, and other relevant standards. The neutral conductor must be bonded to the equipment grounding conductor at the service entrance or main distribution panel. This bonding creates a continuous path for neutral current to flow back to the transformer. Some UPS systems have built-in grounding transformers that isolate the output from the input. In this case, the neutral conductor is not directly connected to the equipment grounding conductor at the UPS. The grounding is provided through the grounding transformer. For UPS systems without internal grounding transformers, the neutral conductor must be connected to the equipment grounding conductor at the UPS. This ensures that the neutral is grounded and that there is a path for neutral current to flow. A cord and plug connection does not typically affect the grounding requirements of the UPS. The neutral conductor should still be connected to the equipment grounding conductor at the appropriate location. The grounding requirements may vary depending on the specific design of the UPS and the electrical system it is connected to. It is always recommended to consult with a qualified electrician to verify the grounding requirements and ensure compliance with applicable codes and standards. With a 4-wire 3-phase 120/208 volts supply and a cord and plug connected UPS, the neutral conductor should still be connected to the equipment grounding conductor at the UPS. Disconnecting the neutral conductor could create a safety hazard and should not be done. It's crucial to understand the role of grounding and bonding in electrical systems, especially when dealing with sensitive equipment like uninterruptible power supplies, or UPSs. These systems are designed to provide a continuous power supply in the event of a power outage, safeguarding critical devices and data. The grounding system ensures that any fault current has a safe path back to the source, preventing electrical shock hazards and minimizing the risk of equipment damage. Bonding, on the other hand, connects all non-current carrying metal parts of the electrical system, creating a low impedance path that facilitates the operation of overcurrent protection devices like circuit breakers and fuses. In the context of a UPS, proper grounding and bonding are essential for several reasons. Firstly, they protect personnel from electric shock in the event of a ground fault. Secondly, they help to maintain the integrity of the UPS system by preventing circulating currents and reducing electromagnetic interference. Thirdly, they ensure that the UPS operates correctly during a power outage, providing a stable and reliable power supply to connected devices. When installing a cord and plug connected UPS, several key considerations must be taken into account to ensure proper grounding. Firstly, the neutral conductor, which carries the return current from the load, must be properly bonded to the equipment grounding conductor at the service entrance or main distribution panel. This bonding creates a continuous path for neutral current to flow back to the transformer, minimizing voltage drops and ensuring stable operation of the UPS. Secondly, the equipment grounding conductor, which provides a low impedance path for fault current, must be properly connected to the UPS chassis and to the grounding electrode system. This ensures that any fault current will be safely conducted back to the source, tripping the overcurrent protection device and preventing electrical shock hazards. Thirdly, the cord and plug connection itself must be properly rated for the voltage and current requirements of the UPS. It's essential to use a heavy-duty cord and plug that are designed to withstand the rigors of industrial or commercial environments. Fourthly, the UPS must be installed in accordance with all applicable electrical codes and regulations. This includes ensuring that the wiring is properly sized, that the grounding system is properly installed, and that the UPS is adequately protected from overcurrents. There are two main types of UPS systems with regard to grounding. Firstly, those with internal grounding transformers, and secondly, those without. UPS systems with internal grounding transformers isolate the output from the input. In this case, the neutral conductor is not directly connected to the equipment grounding conductor at the UPS. The grounding is provided through the grounding transformer, which creates a separate, isolated ground for the output circuit. UPS systems without internal grounding transformers require the neutral conductor to be connected to the equipment grounding conductor at the UPS. This ensures that the neutral is grounded and that there is a path for neutral current to flow. In either case, it's essential to follow the manufacturer's instructions carefully and to consult with a qualified electrician to ensure that the UPS is properly grounded. The National Electrical Code, or NEC, provides comprehensive guidelines for grounding electrical systems. Article 250 of the NEC covers the grounding and bonding requirements for all types of electrical installations, including UPS systems. Some of the key provisions of Article 250 that are relevant to UPS grounding include, firstly, the requirement for a grounding electrode system, which must consist of one or more grounding electrodes that are bonded together to form a low-impedance ground path. Secondly, the requirement for an equipment grounding conductor, which must be installed in every branch circuit and feeder and must be connected to the grounding electrode system. Thirdly, the requirement for bonding all non-current carrying metal parts of the electrical system, including equipment enclosures, raceways, and metal piping. Fourthly, the requirement for specific grounding methods for different types of electrical systems, such as separately derived systems and isolated power systems. Complying with the NEC grounding requirements is essential for ensuring the safety and reliability of electrical systems. Failure to properly ground a UPS can result in electrical shock hazards, equipment damage, and even fires. Therefore, it's crucial to consult with a qualified electrician to verify the grounding requirements and ensure compliance with applicable codes and standards. In addition to the NEC, there may be other local codes and regulations that apply to UPS grounding. These codes may vary depending on the location and the type of installation. Therefore, it's essential to check with the local electrical inspector to determine the specific grounding requirements for a particular project. Disconnecting the neutral conductor from a UPS can create a serious safety hazard. The neutral conductor provides a return path for current to flow back to the source. If the neutral conductor is disconnected, the current may find an alternative path back to the source, which could be through a person or through equipment grounding conductors. This can result in electrical shock, equipment damage, and even fires. Therefore, it's crucial to never disconnect the neutral conductor from a UPS unless specifically instructed to do so by the manufacturer or a qualified electrician. In summary, the grounding requirements for cord and plug connected UPS systems are complex and depend on a variety of factors. It's essential to understand the role of grounding and bonding in electrical systems and to comply with all applicable electrical codes and regulations. Consulting with a qualified electrician is always recommended to ensure that the UPS is properly grounded and that the electrical system is safe and reliable. Let's delve deeper into some of the specific aspects of UPS grounding and bonding. Firstly, the size of the grounding electrode conductor is critical. The grounding electrode conductor connects the grounding electrode system to the equipment grounding bus in the service entrance or main distribution panel. The size of this conductor is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. Using an undersized grounding electrode conductor can limit the effectiveness of the grounding system and increase the risk of electrical shock hazards. Secondly, the type of grounding electrode used is also important. The NEC recognizes several types of grounding electrodes, including firstly, metal underground water pipes, secondly, metal frames of buildings, thirdly, concrete encased electrodes, and fourthly, ground rings. The type of grounding electrode used will depend on the site conditions and the availability of suitable electrodes. In some cases, it may be necessary to use multiple grounding electrodes to achieve the required grounding resistance. Thirdly, the bonding of metal enclosures and raceways is essential for creating a low-impedance ground path. Metal enclosures and raceways that contain electrical conductors must be bonded together into the equipment grounding conductor. This ensures that any fault current will be safely conducted back to the source, tripping the overcurrent protection device and preventing electrical shock hazards. The bonding connections must be made with listed connectors and fittings, and they must be installed in accordance with the manufacturer's instructions. Fourthly, the use of surge protective devices, or SPDs, can help to protect UPS systems from voltage surges and transients. SPD are designed to divert surge current to ground, preventing it from damaging sensitive electronic equipment. SPD should be installed at the service entrance, at the UPS input, and at other critical locations in the electrical system. They must be properly grounded to ensure their effectiveness. Fifthly, the importance of regular inspections and maintenance of the grounding system cannot be overstated. Grounding systems can deteriorate over time due to corrosion, loose connections, and other factors. Regular inspections can identify potential problems before they become serious hazards. Maintenance should include tightening connections, replacing corroded components, and testing the grounding resistance. Sixthly, it's crucial to document the grounding system. A detailed record of the grounding system, including the location of grounding electrodes, the size of grounding conductors, and the type of bonding connections, can be invaluable for troubleshooting problems and for ensuring that the system is properly maintained. The documentation should be kept in a safe place and should be readily available to qualified personnel. Seventhly, training is essential for anyone who works with electrical systems. The electricians, technicians, and other personnel who install, maintain, or troubleshoot UPS systems should receive thorough training on grounding and bonding principles and practices. This training should cover the requirements of the NEC as well as any applicable local codes and regulations. Eighthly, the use of isolated ground receptacles can help to reduce noise and interference in sensitive electronic equipment. Isolated ground receptacles have a separate grounding conductor that is isolated from the normal equipment grounding conductor. This can help to prevent ground loops and other sources of noise from affecting the performance of the equipment. Ninthly, the grounding impedance of the system is critical for safety. The grounding impedance is the total impedance of the ground fault current path from the point of the fault back to the source. A low grounding impedance ensures that the fault current will be high enough to quickly trip the overcurrent protection device. The NEC requires that the grounding impedance be low enough to limit the voltage to ground to a safe level during a ground fault. Tenthly, it is always crucial to consider the specific application when designing a grounding system for a UPS. The grounding requirements for a UPS that is used in a hospital or other critical facility may be different from the requirements for a UPS that is used in a commercial office building. The specific requirements will depend on the type of equipment that is being protected by the UPS and the potential consequences of a power outage. Grounding and bonding are essential components of a safe and reliable electrical system. Proper grounding protects people and equipment from electrical shock hazards and helps to ensure the proper operation of electrical equipment. By following the guidelines of the NEC and consulting with a qualified electrician, it is possible to design and install a grounding system that meets the specific needs of a UPS application. Always remember that electrical work can be dangerous. If you are not qualified to work on electrical systems, it is essential to hire a qualified electrician. A qualified electrician has the training and experience to safely and properly install and maintain electrical systems. Working with electricity without proper training can result in serious injury or death. Now let's consider some common misconceptions about grounding and bonding. Firstly, some people believe that grounding is only necessary for safety. While safety is certainly a primary concern, grounding also plays an important role in the proper operation of electrical equipment. Grounding helps to stabilize voltage levels, reduce noise, and prevent damage from voltage surges. Secondly, some people believe that all grounding systems are the same. In reality, there are many different types of grounding systems, each with its own advantages and disadvantages. The type of grounding system that is appropriate for a particular application will depend on a variety of factors, including the type of equipment being used, the site conditions, and the applicable codes and regulations. Thirdly, some people believe that grounding is a one-time thing. In fact, grounding systems require regular inspection and maintenance to ensure that they are functioning properly. Grounding connections can loosen over time, and grounding conductors can corrode. Regular inspections can identify potential problems before they become serious hazards. Fourthly, some people believe that they can save money by cutting corners on grounding. In reality, cutting corners on grounding can be very costly in the long run. Improper grounding can lead to electrical shock hazards, equipment damage, and even fires. The cost of repairing these problems can far outweigh the cost of proper grounding. Fifthly, some people believe that they can rely on the utility company to provide adequate grounding. While the utility company does provide a grounding electrode at the service entrance, it is the responsibility of the building owner to ensure that the grounding system within the building is properly installed and maintained. The utility company's grounding electrode is not designed to protect equipment within the building from voltage surges or other electrical problems. In addition to the NEC and other codes and regulations, there are a number of industry standards that provide guidance on grounding and bonding. These standards are developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. These standards cover a wide range of topics, including grounding system design, grounding electrode selection, and grounding system testing. Consulting these standards can help to ensure that a grounding system is designed and installed in accordance with best practices. Finally, it is important to remember that grounding and bonding are complex subjects. If you have any questions about grounding or bonding, it is always best to consult with a qualified electrician. A qualified electrician has the training and experience to answer your questions and to help you design and install a grounding system that meets your specific needs.